Right, today in geometry, we are looking at section 10.3, properties of chords. So let's start out. Recall a chord is any segment with endpoints on the circle. Any chord divides the circle into two arcs. A diameter divides the circle into two semicircles. Any other chord divides the circle into a major arc and a minor arc. So we talked about this yesterday. And then here we have the picture of that. Right, so here we have that CB is our diameter. And so we have semicircle on top, semicircle on the bottom. Here we have, this is our chord. So we have minor arc, major arc. So today we're going to learn some theorems that deal with chords. So the very first theorem tells us that in the same circle or in congruent circles, and remember yesterday we learned that congruent circles mean they have the same radius. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in this picture here, arc AB is congruent to arc CD if and only if AB is congruent to CD, those segments, right? So we're going to look at an example using that. So it says in the diagram, circle P is congruent to circle Q, and we see that they have the same radius. FG is congruent to JK. The measure of arc JK is 80. Find the measure of arc FG. Well, they have to be the same. So the measure of arc FG would also be 80 degrees. Okay. So two minor arcs are congruent if and only if their corresponding chords are congruent. And so since they told me that this chord JK and GF were congruent, then I know that their minor arcs are congruent. All right, the next theorem. If one chord is a perpendicular bisector of another chord, then their first chord is a diameter. So in this picture, we see if QS is a perpendicular bisector, remember perpendicular means 90 degrees and bisect cuts in half. So QS cut in half TR, then QS is the diameter of that circle. Theorem number 3, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So this is kind of like the converse of the one above it. Okay? So if EG is a diameter and EG is perpendicular to DF, then HD is congruent to HF, and GD, that arc, is congruent to arc GF. All right, let's look at one more theorem on the back. So here it says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so here it tells me that AB is congruent to CD if and only if EF is equal to EG. So if that's the same distance, then I could say that these chords are the same. All right, so let's try some problems out using all of the stuff we just talked about. It says use the diagram of circle D. If the measure of arc AB is 110, so this is 110, find the measure of arc BC. I see that they have the same chord, right? That chord is 9, this chord is 9, and that means that their arcs are going to be congruent. So this would be 110 degrees. So now it says if the measure of arc AC is 150, so I need to, this is no longer 110 for part number 2. So AC is 150. Find the measure of arc AB. Well, I know all together it's 360. So the first thing I need to do is 360 minus 150. And that gets me 210. So I know that all of this is 210 together, but I know that these are the same since the chords are the same. So cut 210 in half, and that's going to get me just arc AB, which is 105 degrees. Right, below that, in circle R, segment AB is congruent to segment CD. Arc AB is 108 degrees. Find the measure of arc CD. If the chords are congruent, the arcs are congruent. So this is 108 degrees as well. The crossover here says in the diagram, circle P, PV is equal to PW. So they're telling me that they're the same distance apart from the center. QR is 2x plus 6, ST is 3x minus 1, find QR. So we have the theorem that tells me if they're the same distance from the center, then those chords are congruent. So I would just set them equal to each other. So 2x plus 6 equals 3x minus 1. I need to solve for x, so I'm going to subtract 2x over, so I get 6 equals x minus 1, add 1. So I get x is equal to 7. But I have to plug that in. They asked for QR. So QR equals 2 times 7 plus 6. So 2 times 7 is 14. 14 plus 6 is 20. So the length of that, 20 units. Right, in the diagram, circle C, QR equals ST, which equals 16. Find CU. So now they want to know, okay, what's the length of this from C to U? They told me that QR and ST are the same, they're 16, okay? If those are congruent, then I know that these had to be the same distance apart from the center, so that means they are congruent. So I would say 2x equals 5x minus 9. I'm going to subtract 5x over, so I get negative 3x equals negative 9. So x is equal to positive 3. So now if I plug that in, C to U is 2x, so 2 times 3. So I get CU is equal to 6 units. All right, we've got one more page of notes for today. So on the last page, okay, it says these 3 bushes are arranged in a garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? We want the sprinkler to basically be in the center of that circle. So we want to get a circle and we want to put the sprinkler in the center so that it's the same distance from all of those points. So the very first thing that we're going to do, I'm just going to list our steps. We're going to label the bushes as like A, B, and C. Okay, so I'm going to label like A, B, and C. The second thing that we're going to do now, we're going to draw segment AB and segment BC. So I'm going to connect these. Okay. Now I want to draw the perpendicular bisector. So draw a perpendicular bisector of AB and BC. So remember, I want it to be, cut this in half, 90 degrees. So we're just going to kind of guesstimate here. And then same thing here. So, right. Those perpendicular bisectors are the diameters of the circle that contains ABC. Okay. We want to now find the point where the bisectors intersect. That will be the center of my circle through ABC, and therefore would be equidistant to A, B, and C. So they intersect right here. That's where we should put our sprinkler. Okay. So we were using all of a bunch of the theorems that we had talked about earlier, okay, to solve this one problem. All right, so next problem. Use the diagram of circle E to find the length of segment AC and then tell what theorem you used. Okay. I see that this is perpendicular, so BD and CA are perpendicular. Therefore, BD is the diameter. It's perpendicular to AC. Therefore, the diameter bisects AC. So if AF is 7, FC is also 7. Okay? Therefore, AC would equal 7 plus 7, 14 units. That was theorem number 3 from our notes. All right, our last few examples use the same picture. So let's find the measure of the indicated arc in the diagram. We see again that BD is perpendicular to CE. So BD is the diameter and it's bisecting CE. and therefore bisecting arc CE. So now I know that this arc and this arc are the same. So if they want me to find arc CD, I need to set the two arcs together, equal to each other. So 9x equals 80 minus x. So add x over, I get 10x equals 80, x equals 8. So now plug that in, 9 times 8, arc CD is 72 degrees. So I know that's 72 degrees, but then I also know this one's 72 degrees. So that's the next question, arc DE. I know it's 72 degrees because I know that they're equal. Arc CE, well, that's just the arc addition postulate. So 72 plus 72 gets us 144 degrees. All right, that wraps up our properties of chords 10.3.